Okay, before we start this video, you should go through pages 149 and 151 and do those problems. So stop the video, go do those problems on Minitab, and once you've done those, come and compare the answers with what we'll be doing at this time. Okay, so if you go to page 149, just to note that it's standard practice that if you do a polynomial regression model, let's say a cubic equation, then you need to include the x and x squared. So if you have one that determines an x squared term, but not a term with x1, then this model really doesn't make sense. You really should have an x1 term in there. And to say that the vertex of the parabola must exactly lie on the vertical axis, it just doesn't quite make sense for this. So the idea is that if you take the big brother x cubed, you have to take the little ones, x squared and x as well. I was the little brother. My mom always had me go along with my brother. It's an unfortunate part of life for everybody. But if you're a little brother, you can go without the big brother. So that's the kind of idea. If you include the highest degree, you've got to include all the lowest degrees as well. Okay, just as a reminder, how you could do this on Minitab is that you can select the model and then the model, take the terms through the order, and in this case, for example, a quadratic will do an x squared and so forth. And there will be the answers, but first let's go ahead and do that. So here I've got the log ratio and the time. So I'm now here on page 150. And you can fill in the answers. There I've got my equation, negative 2.94 plus 0.06597. It asked me for my r squared, 71.4. That's pretty good percentage, 71.4%. That's looking pretty good. And my mean squared error, or my sum squared error, is 47.71. If I take 47 divided by 32, I get the 1.491. And if I take the square root, I get the residual standard error of 1.22, so you could fill that in. All right, so let's go down to the quadratic regression model. I go to stat, regression, I fit the regression model. Here, remember, I sneak on down here to the model and put the second degree order, and then I hit add. That's one thing to do to make sure that you've got your terms in there of time and time squared. So again, what I had done, I'd hit model and done that and hit OK. And here's my equation. And lo and behold, it matches up with what's in the book. The question, my r squared is now 91.15%. Remember, every time we add a predictor variable, our r squared is going to go up. But in this case, it went up dramatically. That gives me evidence that I should probably keep it in. My sum squared error is 14.76. Take 14.76 divided by the degrees of freedom is 31. I get the 0.4762. Take the square root of the 0.4762 and I get my residual standard error of 0.69. But the question is, does our regression model add value to the model? If I take a look at it and take negative 0.2510 minus 0 divided by the standard error, I get negative 8.32, which is pretty far away, and my p-value is going to be 0. So I have pretty strong evidence that I should include the x squared coefficient into my polynomial regression. It provides significant evidence, but just remember that there is a warning that I shouldn't settle on this unless I've done a full analysis, and until a residual analysis for the quadratic models checks this out. And so you should carry out this regression analysis. Matter of fact, maybe we should just kind of do a brief version here. Make sure that my model is still the square term. And I could do a graph. You should probably, I can select the 4 and 1. And I go ahead and do that. And I take a look. The probability plot's a little bit modeled, but okay. The versus the fit. Got this one big outlier that may change. So I may want to take a look at that to see that happens. But it's pretty good as far as a residual analysis. There actually might be another model besides a squared term. Okay, let's go to number 3, the cubic equation. So this time I'm going to fit a cubic equation of this. So I go to my model, and instead of one term, well, first of all, let's go ahead and delete these terms. Hit the red X, just as precautionary, and then I go to the third model and then hit add, and hit OK. And there I get my new equation, and you should write that down. My r squared is now 91.85%, a little bit better than what I had with the 91.2%, but not a lot. And if I look at my sum of square error, I've got 13.594. Take that divided by 30, I get my mean squared error is 0.545. Take the square root of that, and I get my residual standard error as 0.673. So the question is on the top of page 151, does the addition of the cubic term help us fit significantly? Well, what you'd end up doing is taking beta 3 here, which is 0.00132. Since my null hypothesis would be that beta 3 is 0, I take this minus 0 and then divide by the standard error. And my standard error would be 1.61. I would then take a look at the probability distribution plot of a t-distribution, now with 30 degrees of freedom. And I want to look at the shaded area, and I'm going to do both tails, and my x value turned out to be 1.61. And if I graph that, then, oh, I only did one side. Let's try that again. Got my t-distribution, shaded area. I want both tails, 1.61 as my x value. Turns out to be, I get 0.5894. If I add those two together, I then get this 1.19. And since that's bigger than my significance level, I would fail to reject the null hypothesis and maybe conclude that the cubic equation is not needed. Okay, so let's go on to number 4, the quartic regression. If I try to regress with the fourth regression, Minitab is not going to let me do it. If I hit the model, I only get 3 terms here. It doesn't give me the fourth term. So that's kind of odd. But if I take a look at the data itself, there are only 4 different values, 72, 25, 3, and 0.5. And so I'm asking it to really define 5 parameters for only 4 different x values. So it can't do it. So let's just go ahead and do it where we copy the columns, times squared, times cubed, and times to the 4th. Remember, we can go up here to the calculator and store in C3 time times time, and it captures all that data. 0.5 is 0.5 squared, and then go up to the calculator again and store this in C4 times time. Wow. And then finally, for the quartic equation, go to the calculator again. This would be in C5. My time times, well, I'm losing track of time. Okay, so I think I have 4 times there. And now look what happens if I try to fit a regression equation with this. So I go to stat, regression, and fit the regression model. My y response is still log ratio. But if I put all 4 of these columns in, notice what happens at the very top here. It says here the following terms cannot be estimated and were removed. And so it only goes down to the time cubed. And so this is an example of overfitting the model. So if I don't have enough different x values, I can't fit a higher enough equation. So again, if you can compare your answers to what you have here, notice that the degrees of freedom go down 32, 31, and 30, and kind of gives you all those expressions. You can check your answers there. You can pause it here and check your answers that you got. And then this is our test of hypothesis that beta 3 was 0, the alternative is not. I get a t-statistics of 1.61, a p-value, and I fail to reject. and then Minitab refused to include the quadratic term, quartic term, because it overfit the data, which is the problem. Okay, so that's the process that we went through, and I hope you've got those answers.